Welcome to solverfy.
Okay, in this problem we have a rigid rod in 1D and it has a nonlinear charge distribution on it. It's proportional to its position x. We are asked to find the electric potential in the middle of the rod as we move up in y. And we were asked to find the electric potential moving along the x-axis, v of x. Now to start, we can look at the y-axis for part A. So we're going to look at v moving along this line in the middle of the rod. So recall, for an arbitrary charge distribution, the electric potential we can get by integrating up little pieces of charge. The general formula is we're integrating over charge over r. So here we can change our dq differential and express it in terms of a dx differential as ax delta x. That's a little piece of charge over r. And we can replace our r with root x squared plus y squared, making use of this right triangle. And here's our little piece of charge. So it's a pretty tricky integral to solve, but we can do it. However, it might be worth noting that because this is even with respect to the origin, it's equal to 0. Okay, so let's look at along the x-axis now. This is a little bit trickier. We'll give ourselves a little bit more space. So once again, we start with the generalized electric potential by integrating a little piece of charge over the distance from the charge to our point of interest. We can simplify that integral. We can integrate it from negative L to L of our rod, assuming that's length 2L. We can change our dq differential, and we can express the distance as x. This is the x out to our position, x, minus x prime, which is the x location on the rod. So we're actually integrating over the prime variables. These are pieces of x on the actual rod. We can pull out some constants before we do the integral. We can pull out this a. We're left with an integral that looks like this. So here we can do a substitution. It's probably our best approach. So we can define a new variable z to be this x minus x prime. And this will make our integral. We will get an equivalent integral rather. Remember, we have to change our bounds for this new equivalent integral. X minus z dz all over z. And if we evaluate this integral, we will end up with x natural log of z minus z all over x plus l, x minus l. And with a little bit of natural log math, some log rules, we can get it in the form x natural log of x plus l over x minus l minus 2l. And this is only valid for x greater than l. So that's it.